Morning, sir.
Hey, good morning, guys. So, can anyone tell me what was the last topic that we have discussed in the Thursday batch, not in the Sunday? Good morning, Rakesh. What was the last topic in the Thursday batch?
Hello, hello, packets.
Hmm?
EIGRP budget.
EIGRP. Oh, yeah, yeah. EIGRP Hello Packet, right? So we have
Yeah.
done with the EIGRP Hello Packet, and we have seen some, like, the neighborship criteria, right? If I'm not wrong.
Yes, sir.
Yep, good. Perfect. So, guys, your one topic is remaining. That's EIGRP summarization that yesterday we have seen that, right? Leak map concept, right? We'll discuss this thing on the Wednesday, right? Because let me complete all the season stuff from you guys, right? Then I'll go to the leak map. Okay. Okay, let's remove this guy. Not interested. So we have some network behind this guy. So 1.0.0/8, and we have some network behind the R2 2.0.0/8, right? I want to provide the communication between these two guys, right? Okay. Let's do one thing. Let me take a screen and I'll paste in the paint file. Perfect, right? So now, okay, come to the CLI. Three more. All cool. So R1, let's configure the IP addressing, whatever the things are given in the diagram. So interface 0/0 IP address will be 12.1/24. No shutdown. Interface loop. Oh, come on. Interface loopback number one. Interface loopback number one IP address /8 over there, right? Done. Save this configuration to R2. Interface 0/0 IP address will be 12.2, right? And /24, no shutdown. And interface loopback number one IP interface. Come on. Interface loopback number two and done. Save this configuration, right? What is the next thing we have to do, guys? I need to first, what I told you, that if this two-person wants to communicate, there is a user behind the R1 and there is a user behind the R2. If this two-person wants to communicate to each other, first of all, you need to establish the neighborship and adjacency between these two guys, right? Once you have formed the neighborship adjacency, then after that you can exchange the update, right? And then they can communicate to each other. How will I form the neighborship between these two router? By sending the hello. And how I will send the hello from this interface? By enabling this interface into the EIGRP routing protocol, right? And how will I do that? Just putting the network statement, right? Network 2.0 and R2 router EIGRP number one, network 2.0. That's it. This was the hello packet, right? If you see do debug EIGRP packets, so what happened? R1 will keep sending the hello packet to the R2 and R2 will keep sending the hello packet to the R1. It means that both this router is going to exchange the hello packet to just maintain the neighborhood at every 5 seconds, right? So if the router will not receive, right? If the router will not receive any hello packet from my neighbor, the router will wait for the 15 seconds, right? That's the hold on time of the GRP. If I'm not receiving any hello packet within a 15 second, I will declare my neighbor is dead, right? So you can see that my neighbor is sending and receiving the hello packet. It means that both are working fine. And if you capture this link as well, as I'll do one thing. just for the reference purpose. Capture, and I'll take the screenshot. And in this EIGRP hello packet, you will have a hold on time information. You can see that, right? And I also told you that if the, if you're going to reduce your hold on time, right? If you're going to reduce the hold on time lower than the hello, you will have a flapping of the neighbor, right? You're not going to drop the neighborship, you will have a flapping of the neighbor. And I'll restore. All good. Now I'll do one thing. I'll take out this screen as well, as that's important. And let me reduce the size. Perfect, right? So you can see that R1 is sending the hello packet to the R2, and R2 will send the hello packet to the R1 as well as. So R1, R2 will receive, this is the debug of R2 daughter. So you can see that R2 is receiving the hello packet from my neighbor 12.1, and I'm sending the hello from 0/0 interface. That is this guy, right? R2 is sending the hello packet from this interface 0/0. Now, what I want, this thing we have seen in the last classes, what I want over there, I want to provide the communications between these two guys, right? The PC number one, that's belong to the R1, and PC number two, that's belong to the this side. And these two guys, this guys are belongs to the 1.0.0/8 subnet, and this guy also belong to the 2.0.0/8 subnet. What we have to do, we need to share this information. How do I share this information? Like this, on the wire I can put this information like this, 1.0.0.0/8. On R2, I'm gonna R2 and say that, hey, I'm gonna advertise this network. So will R2 will share this information like this? No. All this information has to be encapsulated, right, with the new packet, and that is called as a, all this new information is going to encapsulate with the new packet, that is called as a update packet. That is called as a update packet. It's not like that I can put this information in the EIGRP hello packet. I need to create a new packet over there, and in that new packet I'm going to put this information 1.0.0/0. Whatever the information you have, whatever the information that you're advertising, all that information will be seen in the update packet. Your update packet has a three tab. One, it contains the route information, right? Update packet can be multicast as a multicast, and unicast as well as. Your update packet has three tabs. Null update packet, that does not contain any information, is used to like, we can say that in an easy way, right? What is the time is happening. Yeah. Next packet is full update packet. It, and when a router first form the neighborship, It's send a complete routing information, right? Only the full, like your, you can say that it's like your, rep periodic update, right? But this full update, it only send when the router will first form the neighbor shift, right? And second is a third is a what? It's a, what do you call, null full and trigger update. Someone mic is on. Can you disable your mic? It whenever router will advertise some information, it only put truth information in update packet, not complete routing information. And this update packet is a reliable packet. And who will provide the reliability? RTP protocol provide reliability to EIGRP packets. RTP reliable transfer protocol is a layer 3 protocol introduced by, so RTP only provide reliability to EIGRP packets. Now, if you have a look right now, stop this guy, and if you come back, go, come on, show me. Okay, they already found the membership. Then after that, I think so I open, but I should not a big deal. I'll do one thing. I'll capture again. Stop capture. Start capture. And on a R1, right? I'm going to create some look back, more look back on R1, right? Let's take example interface look back number 2. What we call 101. Interface look back number 3. Interface look back 3. Sorry, 4. And let's do one thing. I said the node of EIGRP number 1. I disable the EIGRP, and I'm going to advertise now EIGRP. Before I'm going to advertise, let's capture, and so that I can show you all the update. And router EIGRP 1 network 0.0.0.0.0. From done updates, and we are good to go. This update packet. This update packet does not have any routing information. This is called as a null update. They don't have any routing information, right? They're just going to use to calculate the SRT. How much time it taken from router 1 to the router number 2 to get the acknowledge, right? What's the distance, we can say that in normal language, right? So this is my null update packet. I'll do one thing, I'll paste it over there. This is my null update. They don't have any routing information. Can you see that there is no routing information over there? This is a null update. That does not contain any information. After that, Now this one. Can you see that this is called as a full update? I have a complete routing information. R1 is setting to the R2, right? I'll show something like this over there. Come on. Yeah. Yep. So this is the full update. When router first formed the neighborhood, it sent the complete routing information like a RIP periodic update, but it's not a RIP update, right? And same the complete routing information in a single update. And the third one, for that one, I need to restart my Wireshark menu. That stop capture, start capture, and start Wireshark. And I'm going to create on a router one loopback interface loopback number. Take example 200, and the IP address will be 200.200.200.200.200 slash 24, and done. And now R1 is sending what update? Trigger update. I'm not going to send the complete routing information. See the this is right. This is called as a trigger update, right? I'm not sending the complete routing information. If you remember that in the EIGRP, what happened? If you're just advertising a one route, the router is keep sending the complete routing information. But in the case of EIGRP, it does not. It only send the those information that I'm generating. And this is my trigger update. Only the specific information, not the complete information. So your update packet can be multicast, and it can be unicast as well as, right? So in the case of null update packet, it should be unicast because R1 is sending the null update packet to the R2. Okay, R1 is in the null update packet to the R2, right? They does not have any information, right? It's sending, hey, I've sent the null update packet to the R2, and what R2 will do? R2 will give the acknowledge of this packet, right? So the time interval between these two packets, because I'm sending this packet from my this interface, right? R2 receive and R2 is giving the acknowledge of this update packet. So the time interval between these two packets, right, is known as a SRT, a smooth round trip time. Like for example, this is me. I have to start my journey from my room, right? And what happened? I reached to the network home. Take example. So I start my journey of 11:25, right, AM. And what happened? Came back from the NS to the my home room again. So what happened? I'm coming by 11:40 AM. So the time interval is what? 15 minutes. This is called as a SRT. And your EIGRP update packet is a reliable packet, and who will provide the reliability? Your RTP protocol provide the reliability. It only provides the reliability to the EIGRP packets. It's a Cisco proprietary protocol. It's a layer 3 protocol introduced by the Cisco. It means that whenever the router will send the update packet, right? Whenever the router will send the update packet, R2 always give the acknowledge. If you have a look, I'm just going to router number 2 now, and I'm going to advertise this route. And before I'm advertising, I'll say the debug EIGRP packet to the TERS, right? Debug EIGRP packet. Okay, I don't want to this debug. You all debug EIGRP packet TERS. See, there's a two keywords over there. One is if you see, I'll do one thing. I'll explain you this part. Come on. Yep. Debug EIGRP packets. See, two keywords are there. One is the debug EIGRP packeters and one is the debug EIGRP packets. If you put the debug EIGRP packet, you can see the hello packet sending and receiving, right? But that is actually I don't want, because this packet is a periodic packet, right? This packet is a periodic packet that hits on the CPU every time. I don't want to see this debug. I only see the reliable packets. Debug EIGRP packets does not reliable except the hello packet, because hello is a periodic, right? On R1, I also enable the debug IP packeters and also the debug IP routing. And can you see on R2 what I can do? On R2, I'm going to advertise this route 2.0.0.0.0. Which update packet R2 will send? R2 will send the trigger update packet to the R1. And in this trigger update packet, what happened? They will put the /8 information that's going to represent that it's a classless routing protocol, right? What R1 will do? R1 will give the acknowledge of this update. Have a look. R2 is sending. I'm including the update on 0/0 interface. And what R1 will do? R1 will give the acknowledge. 1 minute, you all. Also in the Wireshark as well as update. R2 is in the update packet, right? And R1 is giving the acknowledge. Open the update and acknowledge. So if you have a look on R2, R2 is in this update packet, right? That on this network I have advertised 1202. And what R1 is giving? R1 is giving the acknowledge. Your acknowledge packet always will be unicast. The thing is that your acknowledge packet and hello packet both are same. If you have a look, I'll show you. Can you see that one thing over there? This is your hello packet and this is your acknowledge packet. Both are same. I'll do one thing. I'll take a screenshot and I'll paste it over there. And I'll paste over there. I'm going to remove this person now. And I think that's great. If you see over there, what happened? Both are hello packet, right? Only the thing is that in your hello packet, right? This is your hello packet. Your hello packet is your multicast, right? But your acknowledge packet will be a unicast. Opcode are same, both have a same opcode value, 5 and 5, both have a same opcode value, right? But only the difference is happening. Your hello packet is a multicast packet, right? It can be unicast in some scenario, but normally it's a multicast on the broadcast media, right? And it's a unicast. Another difference is that your hello packet does not contain any kind of sequence number, not an acknowledge number. Can you see that? Even if you see the flag over the sequence and acknowledge number, nothing is there. This 0 is going to represent that is a, you know what I call it, this is the sequence number and it's the acknowledge number, right? Both are 0 in the hello packet, and that's why it's calling that hello packet is not a reliable packet. But if you see the acknowledge packet contains the acknowledge number. They don't have a sequence number, but they have acknowledge number. Also, your acknowledge packet is not a reliable packet because they just have a acknowledge number. If you have a look, when R2 is in the update packet to the R1, what R1 is giving? R1 is giving the acknowledge. And if you see over there. Can you see the difference? This sequence number we have a and acknowledge number. The first one, right? The first one, this one is your sequence number, and this is your acknowledge number. So same thing, if you see the acknowledge packet, in the acknowledge packet, what happens? Sequence number is 0, that is this guy, right? And acknowledge number we have a 9, that is this guy. So the main difference between the hello packet and acknowledge packet, hello packet is a multicast, your acknowledge packet will be a unicast. Second thing is that in some case hello packet also will be a unicast. Okay, and second thing is that your hello packet does not have any sequence number acknowledge number, but your acknowledge packet has the acknowledge number. Which acknowledge number? That you have sent. For example, if you see the update packet, in update packet, what sequence number I'm using over there? Can you see that? Your update packet, what sequence number I'm using? 9. So what happened? Acknowledge is also 9. Acknowledge packet, right? So R1 is in the update packet with the 9 sequence number. He's giving the acknowledge with the same sequence number. He's just informing, hey, I received your update packet. It means that EIGRP is reliable protocol. What I told you, if you remember the first day of the class, I told you the IP is not reliable, right? And still EIGRP works on the which protocol? IP. So what people are thinking, right? EIGRP is also not reliable, but EIGRP is reliable. But EIGRP is reliable protocol. And who provides the reliability? RTP. So every time your update packet, right? Not update packet, your sequence number, your sequence number and acknowledge number, both are sizes 32-bit. And every time sequence number will increase by 1 every time. So if you see right now, what's the sequence number is happening? 9. Let's create another update. Do debug EIGRP packet just right, and as the network 3.0.0.0. Which sequence number I'm going to send? Sequence number 10. Done. Do you all? What sequence of data I'm sending? 10. What R1 is giving the acknowledge? 10. If I'm going to get the new update, interface loopback number 5. Right. Router EIGRP number 1 network. Which sequence number I'm going to send? 11. Done. And receiving is what? Done. So every time your sequence number will be incremented by 1. And how do I know this packet is reliable? Based on the sequence number. Your hello packet and acknowledge packet is not reliable. They don't have any sequence number concept. They acknowledge packet only have acknowledge number. but update packet contains the sequence number. If you see any update packet, right? Have a look at any update packet. If you see the trigger update packet, if you see the in like your what we call full update packet, and if you see the null update packet, can you see the first always start from the one? Zero is reserved. You cannot use the zero, right? Now take example router one, you switch router number two, router number three. Three routers are in this domain. Guys, just pay attention. R1, R2, R3, switch, interface 0/0, right? 2, 3. Now, the subnet I'm going to use over there, it's a 192.168.1.0/24, right? On a router number one, I have configured the command router EIGRP, one network 1.0 and network one loopback, right? Network 2.0. This is the two loopback on R1 I have done. And same command on R2 I put. So what happened? This router is going to form the neighborship and adjacency, right? This router will form the neighborship and adjacency. So we have a neighborship and adjacency over there. Now what happened? R1 is going to exchange all this information with the R2, 1.0.0.0.0 and 2.0.0.0, right? So how will they send the update to the R2? They will send the two update packet. One, they will send the null update to calculate the RTU, right? And it will send another update will be complete routing information, the full update, right? And this update packet will be what? It's a multicast, right? Dot 10. Now, after some time, maybe the 2 hours, 3 hours later on, okay, I have enabled the EIGRP on this person now. Router EIGRP number one network 1.0. Now what happened? R1 is going to form the neighborship with this person as well as right. Done. R1 is going to form the neighborship with this person as well as right. And R3 will also going to form the neighborship with this person as well as right. So once R1 will form the neighborship with the R3, R1 has this information in the routing table, right? So in that case, would you know what happened? It also send the what we call null update to the R3 to calculate the SRT. At the same time, now in this case, it will send the full update as well as. But this case, the full update will be a unicast only to the packet source will be 192.168.1.1. That is this guy, and destination will be 3. R1 is only going to send the full update to the 103. It will not send to the R2 again to just reduce the extra processing. And this is the another way to send the unicast packet. It is not because R1 has already neighborship with the R2, right? R1 has already neighborship with the R2. So why should I again send the same information to the R2? So it only send the same information to the R3. Because if I'm doing the multicasting, what happened? It's sent to this guy and this guy as well as. So they already have R2, they already have this information, right? Why should I send the same information to the R2 again? So it only send the R3 like this. Perfect. So this is your update packet, guys. Any questions anywhere in the update packet? 1 minute. Meanwhile, I'll do one thing as well as. Can you see the hello and acknowledge? They have the same opcode value. Hello and acknowledge. Your update packet is a reliable packet because EIGRP makes sure that they are all delivered in a proper order. Proper in the sense of what they're having a sequential concept. Now, read this line. EIGRP send a periodic hello packet that I told you that at every 5 seconds. Once it has been enabled on the router for a particular interface, these hello messages are used to identify the neighbors, verify whether these neighbors are compatible to configure, right? Residing in the common IP subnet using the same. We have already seen each and everything, right? Using the same ES number concept, same key values, authentication if they configure, right? And after once they will form the neighborship, it serves as a keep alive mechanism to between the neighborship. EIGRP hello packet are sent on the link local multicast address. That's IPv6. Forget this one right now. This is the multicast address for the .10, and this is for the IPv6. If static neighbors are configured, the hello packet are sent as a unicast as well as right to the neighbor. If you're going to configure the static neighborship, the default hello timer is 5 seconds, and on the NVMe network, that is our non-broadcast multi-access interface. Like this is the on the time the frame relay we were using, right? We are going to use the bandwidth of the setting 1544 kbps and less. The default hello is 60 seconds. In a simple language, on a slower media, the EIGRP hello packet will be sent on the 60 second, right? EIGRP hello packet have a opcode of 5 and they don't have any acknowledged number. It means that EIGRP hello packet is not a reliable packet. Acknowledged packet. An acknowledged packet is used to acknowledge the selected received EIGRP packets to facilitate their reliable delivery, right? To just facilitate the reliable delivery, nothing else. Acknowledged packet are sent in the response of what? Update. Forget this master right now, we haven't discussed. And they always send the unicasted to the sender acknowledged packet. As compared to the hello packet, EIGRP acknowledged packet essentially a hello packet with the empty body, right? They don't have a acknowledged packet does not have any information that we have seen, right? If you see, they don't have any information. Yep, see that? No information. As compared to the hello, if you see the hello packet, they have lots of information, right? Open any hello packet, they have lots of information. Can you see that? See the difference. Lots of info parameters are there, right? Then we have a software version, lots of information are there, but in the acknowledge packet, no information. That's it, nothing else. Update packet. EIGRP update packet contains the routing information update are used to convey the virtuality of the destination. Update packet can be a both unicasted that we have seen and multicasted as well as, right? Depend on the scenario. During the new adjacency that we can say the neighborship adjacency, the build-up, the update packet are unicasted between the newly discovered neighborship. In the specific case, when the multiple new neighbor are detected on a single multi-axis in a short time span, EIGRP might choose it to synchronize them using a multicast for the efficiency reason, right? Ignore this point right now because this is totally beyond this your syllabus right now, this part. So just depend on the scenario, right? It can be sent as a unicast and multicast as well as, right, during the adjacency. Another way to send the unicast packet. After router have fully synchronized, the further update are sent as a multicast. If the neighbor does not acknowledge, for example, router 1 has sent the update packet to the router number 2, right? And router number 2 is not giving the acknowledge to the router number 1. So what happened? EIGRP will retransmit the update as a unicast to the unresponsive neighbor, right? So if the neighbor does not acknowledge the arrival of the update packet, so R2 has received the update packet from the R1, but R2 is not giving the acknowledge. But R1 will first, it will send the multicast, and after that, they will send the 16 unicast update packet R1 to the R2, only R2. And after that, if they are still they are not responding, R1 will declare, hey, my neighbor is dead. Update packets are delivered reliably, right? They are always acknowledged and retransmitted if no acknowledge is here from the certain time. That's it. This is all about your guys update packet. Let me know if you have any questions from the update. I have seen all the possible scenario in front of you of the update packet. If you have any question from update, let me know.
No,
Hello, sir.
Huh?
So you mean to say through two-way router will declare the neighbor if his neighbor is dead. First
Yeah.
is hello. If we miss three hellos, then router will declare that this neighbor is dead. And the second one is if he is not sending acknowledgement or update packet, and then after 16 times this will declare that this neighbor is dead, right?
Right.
Means two things are there to declare that
Tell me
neighbor.
what happened if the your hello on the slower media, right?
Yeah, yeah.
On the slower media, what I told you, 60 seconds is a hello time, right? What is the hold on time? 180 second, right? I will retransmit the packet at every 5 seconds, right? So solo print, see.
Yeah.
Yeah, yeah. Very
Okay.
good. Understand now?
Yes, yes. Sir, one more thing. Uh, Two types of packets, update packets means one is first time when form neighborship, then that fully updated packet. Then you said that second update, periodic update.
I
That
didn't say the periodic. I never say the periodic update. I never say the periodic.
okay,
I
so
already
it is never sent periodic update, only
never. It's, I say the periodic update.
okay, 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 sorry, okay, okay, got it, got it. Understand.
Now, next information. If you can show IP EIGRP neighbor, what happened? By putting the command show IP EIGRP neighbor, I can get the what is my neighbor information I have. I'm present on a router number one, and just present on router number one, I can get the my neighbor information. What is my neighbor is happening? The first thing is H. H means what? It's a handle. That's just going to represent that, you know, how many neighborship we have. If always start from the 0, then 1, then 2, then 3, then 4, then 5, it means that I have a total of 6 neighborship. Then after that we have a address. Address means what? It's just going to tell you, hey, what's my neighbor address? Neighbor address is 12 or 2. Interface means what? It's going to talk about the local interface number, from which interface I'm forming the neighborship with the 12 or 2. Then hold on time is a 15-second by default. Uptime is what? How many second this neighbor has came up? It's a 25 minutes ago, right? It's an hour, it's minute, it's second. All good. Then after that we have SRT that I told you, right? A smooth round trip time. It means that when R1 will send the update packet to the R2, right? When R1 send the update packet to the R2, 100.0.0.0, I need to get the acknowledge of this update packet. So the time interval between these two guys is known as a SRT, always calculated in the millisecond. After that, we have a R2. R2 means what? It's a read transmit out. It means that, for example, R1 has sent the update packet to the R2, but R2 is not giving the acknowledge. Then what happened? I should wait and then again resend the update packet. Again, I'm not getting acknowledged. Let me resend the. Again, I'm not getting acknowledged. Let me read. That's the meaning of retransmit out. Retransmit. I keep retransmitting if I'm not getting the acknowledge. And then after that, we have a queue count. The queue count is just going to tell you, hey, how many packets are stuck in the queue. Like a queue, you know, the lines are there, line queue. The whenever you go to the bank and you have a lots of line queues are there, right? The people are in the queue to get the own number. The queue count, in this queue count, always the reliable packet will be stuck. If there is any queue count 1, 2, and 3, is there anything is happening, any value except the 0, it means that you have an issue with the neighborship. If there is no queue count, it means that I have sent the queue, I have sent the, like, you know, update packet to you, and you have given me the acknowledge of that one. I can show you something like this. 1 minute. I'll do one thing. Done. And done. Done. R1. Do debug. I'll say that what I call interface loopback number. Then do show IP as a neighbor. You see, click on one. It means that I have sent the, I have applied the ACL over there and deny the EIGRP. Sorry. So in that case, what happened? R1 is send the query update packet to the R2, and R2 is not giving the acknowledge. You can't build one. I've sent the update packet, right? So in the queue count, always your reliable packet will be stuck. Let me do that. Done. Now, come on. Yep. So now I received the acknowledge. After receiving the acknowledge, what happened? Once they R2 will send the acknowledge, I will receive the coupon. And then after that, sequence number. Sequence number is just going to tell you what was the reliable packet that I have sent you. What was the reliable packet I have sent you? So if you see debug EIGRP packeters, get the loop back. Come on. What loop back? 50.50.50.50. Do you all? So what was the sequence number is happening? 9. Do show IP enable. एक मिनट ना. What was the reliable packet I received from my neighbor? Not the, I'm sorry, my mistake, my bad. What was the reliable packet I received from my neighbor? So R1 is in the update packet with the sequence number 9, right? So on a R2, if you see the neighbor information, you have a sequence number 9. So they will just tell you, hey, whatever the reliable packet I received from my neighbor. Received from my neighbor. Clear, right? One more thing, your EIGRP update packet can contains 2 types of route. EIGRP update packet. One is the internal route and one is the external route. Done. Now next input. What happened? What happened if I lose this information? See, here is a little bit interesting concept is happening. What happened if R1 will lose the information? Two things will happen. First of all, once router 1 lose the loopback number 1, two things will happen. First, R1 will inform, not inform, R1 will ask to my neighbor, hey, do you have any alternate path to reach 1000? If they have, it means that R1 is asking to the R2, hey, do you have any alternate path to reach this guy? Because R1 does not have any backup connectivity with this person, right? R1 does not have any backup connectivity with this person. So R1 will ask to my neighbor. If they have, then R2 will send positive reply, and in that reply packet, they put updated information, like your update packet. It's behave like your reply packet is not behave like an updated packet with matrix. If they don't have, then it's send negative reply. No worry, I don't have. And in the negative reply, in that reply, they put infinite matrix information. Infinite matrix, it's an unteachable law. R1 will ask to the name to my neighbor by sending a query packet. In query packet, they put or zero with infinite matrix. Infinite matrix result, this route is not reachable. Two things. The first, this one, and second is what? R1 is informing. Please remove this information from your routing table as well as. This is like, this is, I'm saying this thing, right? It's not like given a book that I'm saying, yeah, is also informed too easy to understand. That's nothing else. But actually, this thing is happening. Who is not able to understand a very technical way? So this is like, R1 is informing to the please, remove this route from your routing table if you don't know about that route. Now, Julie packet, right, is level time. It means that I need to have, I need to know, I need to have acknowledged. It means that if you see right now, if I'm just going to lose the network, I'll do one thing. I'll enable some debug. No, man, please, please, please. That's why I don't want to enable this debug. It never. Do you all? Your absolute back is there on R1 right now. Stop this test. Done. Okay. Go back one. Let's advertise this out. Do debug. EIGRP packet test. And I have to let me remove the hold on time that is configured there. All done on R2 as well as. Do so IP route EIGRP. You can see that I have this information in my routing table, right? Perfect. What happened? R1 interface loopback now shut down. Stop capturing. Capture this link. Now shut down. Shut down. Stop this guy. So if you see what happened, R1 has lose this information, and what R1 is doing, send the query, right? Hey, do you have any information of this guy? What R2 is giving? Acknowledge. This is the query and say acknowledge. What the query sequence node is happening? 7. What the acknowledge sequence node is happening? Acknowledge number 7. Guys, any doubt this point, you can ask me. All clear? Now, after that, what happened? I have asked the also question to the R2, right? Hey, do you know about this path 1.0.0? If R2 know, R2 will give the reply packet. If R with the positive reply, if R2 does not know, R2 will give the negative reply. What R2 is giving? Receive the reply from the 12 or 2. Hey, I don't know about this guy. Right? I don't know about this guy. What happened over there now? What sequence number I'm sending? 20. See, 20. Done. What R1 will go? R1 will give the acknowledge because your reply packet is also a reliable with sequence number. Sorry, acknowledge number 20. So you can see how this thing is happening. If you have a look over there, query that's 12 or 1 is sending 12 or 1 is it dot 10. Capture this guy, not capture, internal out, and I call a legacy metric, right? That's a thing that I want to show you guys, right? And screenshot and paste in the notepad. Painful. Done. Done. Query packet, multicast address, informing to the every person, right? Which route, what metric I'm putting over there? Infinite. Is an infinite metric, infinite delay. Right? And now if you come back to the, come on. If you come back to the acknowledge packet, because I'm sending the query, so I need to have acknowledge. So what R2 is doing? R2 is giving the acknowledge. Open the acknowledge packet. Why I'm saying the acknowledge? Because EIGRP query packet is reliable, right? EIGRP query packet is reliable. I need to have acknowledge. Send me the acknowledge. Acknowledge packet. Right? How do I know this is acknowledge packet? Unicast packet. Maybe you can go. Hello is also unicast, right? They have acknowledge number. Same sequence number that you're sending over there. Then what R2 will also inform, hey, I don't know about this guy. I will send the reply packet. And reply will be unicast. And the reply, what information I'm going to put over there? Same information, man. Because this is the negative reply, right? Not the positive reply. So now, good to go. Reply with what? Unicast. Acknowledge sequence number. Same update. And how do I know that this is the negative reply? Same delay. See? Right? Infinite matrix. For which route? Same route. 1 or 0 or 0, 1 or 0 or 0. Right? And now what happened? Once R2 will send the acknowledge or the reply packet, then R1 is giving it acknowledge. And this acknowledge is for what? This acknowledge for the reply. Done and looks good. You're right. Perfect. So this is the acknowledge packet again, right? How do I know this is acknowledged? Unicast. So maybe a question law, hello is also unicast. See the acknowledge number. That's belong to the this guy. Sequence number 20 and 20. All this proof procedure will happen, guys. First, query packet, then acknowledge, then reply, and then acknowledge. Query, acknowledge, reply, acknowledge. So what is the use of query packet? To inform my neighbor, hey, something goes down, something is bad. And what is the use of reply packet? To just inform, hey, do I have information of that particular person or not? Because I'm going to ask to you, right? Do you know about this guy? Take an example. If something got died, right? What happened? You're asking, hey, do you know about that guy? He died. So you are asking, right? So if they know it, they say that, okay, I know him, right? I know him very well. If they don't know, they know. If they know, then it will also share some information with you. If they don't know, then you stop sharing the information, right? This is how your EIGRP reply and query packet acknowledge packet is going to work. So in conclusion, if I will tell you, your hello packet and acknowledge packet is not reliable. Your query packet, your update packet, and your reply packet is reliable. And who provides the reliability? RTP protocol. And how do I know that this is a reliable packet? Because based on the sequence number. Because this two packet does not have a sequence number. So if you read this line, EIGRP query packet are used to involve the neighbors in the task of searching the best path, informing the another neighbor, hey, do you have any alternate path to the decision? Similar to the update, query are also delivered reliable. Query can be both unicast and multicast. By default on the multicast access interface, only on the dynamic neighborship, it will be a multicasted, and it can be sent as a, multicasting, and it can be sent as a unicast as well as. If the no acknowledge in a proper time by the neighbor, the query will be retransmitted to the unresponsive the neighbor. Don't worry about this line, right? We have almost 2 hours of the discussion, right? In the next Thursday batch, we'll discuss this part almost 2 hours in the Thursday class on point-to-point interface towards the statically configured neighbors. Query are always sent as a unicast, right? So two scenarios are clear to you, all of you. Note that, like a static neighborship, we can say that. Note that while each received query must be acknowledged by sending a acknowledge, right? Acknowledge does not constitute a response to the query message, only an acknowledge that the query has been received. The flowing packet used to respond it by using a reply packet. Why I'm using the reply packet? Just for the, because acknowledge does not constitute a response to the query message, right? That's why we are using the reply packet. Guys, let's done for the today, because there's a huge things will be there. We'll discuss, we have to discuss the reply packet more about this guy, and more about this guy as well as tomorrow class we'll discuss. Okay, any questions for the today class? We have a lots of things, not I'm done.
No, sir.
Perfect, all good. So guys, see you tomorrow. Bye bye, and have a great day, and please do the practice, the summarization that you didn't.
Yeah, okay, sir.
Perfect. Okay.
Yes, take care.
Thanks guys, thanks, be safe.
No, sir.